Hello to everyone. In this experiment, you are going to see about the numerical aperture of the optical fiber. Aim of the experiment is to find the numerical aperture of the given optical fiber. What is optical fiber? We know that optical fiber is a thin transparent wire which is used to carry the data from one end to another end. Especially it's used for the communication purpose. So it consists of a core of refractive index n1 and another thing is cladding of refractive index n2. So this is core and the core is surrounded by cladding, and they both have different refractive index. N1 is the refractive index of core, N2 is the refractive index of cladding. And what is numerical aperture? It is the light gathering capacity of the numerical optical fiber. So now just consider this one is the optical fiber. This one is N0 is the refractive index of air, N1 is the refractive index of core, N2 is the refractive index of cladding. By using this, we are going to find the numerical aperture of the optical fiber. The formula for the numerical aperture is numerical aperture is equal to root of n1 squared minus n2 squared, where n1 is the refractive index of core and n2 is the refractive index of cladding. And then from this, we are going to detect the acceptance angle sine theta. Theta is the acceptance angle. Sine theta is equal to r by root of r squared plus d squared, where r is the radius of the spot, and we'll see in the experiment, and d is the distance between the fiber and the detector. So we are going to see it in the simulator experiment. Okay, and this is the procedure. So see here you are seeing the equipments. This one is the output unit. This unit will detect the radius of the spot, and this one is the detector. Fiber stand is connected between the concentrator and fiber stand. Fiber is connected between concentrator and fiber stand. Concentrator is focused the laser beam into the optical fiber. So this optical fiber is detected by the detector, and the radius of the spot is detected by the output unit. So you have an emitter over here. See, the laser beam from the emitter will fall on the concentrator. This concentrator will make the laser to pass through this optical fiber, so that laser will come from one end to another end. So from the fiber stand, the detector will detect the radius of the optical fiber, and it is detected by the output unit, so that it will get the radius of the laser spot. Okay, and this is a graph. This is between the detector distance and the Imax acceptance angle. Okay, this is, so I'm going to use simulator. For this, using simulator, you have to track all the equipments. So I'm tracking output unit, I'm tracking detector, I'm tracking fiber stand, I'm tracking concentrator, I'm tracking emitter, so that laser will get emitted from this emitter. I'm tracking fiber stand, I'm tracking the optical fiber, which will connect the concentrator and the fiber stand. Now start the experiment. Switch on. I'm selecting, we have two glass fibers, one is plastic fiber and another one is glass fiber. I'm selecting the glass fiber, and I'm selecting the light laser source, green laser source, and the distance between the detector and the stand, I'm just choosing as 5.1. and this detector, this is the distance between the detector and the emitter. So I'm just choosing this one as 0.45. Now show graph, I'm just choosing this distance as 3.25. okay, see the graph. See, this output unit will give you the radius of the optical fiber. Z, the distance is 5.1, X 3.25. Now see the procedure. So you have to note the distance, HSR reading, PSR reading, distance and the output unit I, so that we will get the result. Okay, the radius of the spot. Once again I'll tell you, go to simulator, drag all the equipments, output unit, detector, concentrator, emitter, fiber stand, fiber. Now start the experiment, switch on. I'm just selecting glass optical fiber, just selecting green. This distance I'm selecting as 5.1, and this one detector distance I'm selecting as 3.5. Show graph, so that you will get the detector distance, and the radius of the spot is 0.0035. Okay, so from this we can able to calculate the numerical aperture. So thank you.